top of the line here with this is it's basically, so like OpenMV, what we're trying to do is do computer vision on microcontrollers. We started doing this way before anyone thought you could do computer vision on microcontrollers. So back in 2015, that's when we started working on it, about 10 years ago. So we were about 10 years early on starting to work on things, but that helped, though, prepare for where we are now and getting our software to the point. Bootstrapped it for 8 years and then went full-time about 2 years ago. It'll be, it was 2 years in March, and so we're a little bit beyond 2 years full-time. Well, I guess I officially got terminated from my job in June 2 years ago. So that's officially when the company shut down. I no longer had a job, but the company shut down BART trucks back in March of 2023. Anyway, so worked really hard, and what we were able to produce is something like this called OpenMVCAM AE3. Yeah. And so this is our next generation OpenMVCAM, the size of a quarter. And it features a 200 billion instructions per second neural network, NPU on board. And then we have the OpenMVCAM N6, which is based on ST's processor, the STM32N6. And for some reason, my camera is not refocusing to me back here. Yeah, that's okay. It's keeping it focused on right up here for some reason. But anyway, that's the N6, and so this is a very powerful camera. Also, it features a 600 billion neural net instructions per second neural network accelerator. The key trick here is, and then finally, what's the extra kicker is that both of these processors now feature something called the Cortex M55, which supports vectorized DSP instructions, which allow you to get up to generally about 4x the performance, sometimes up to 8x the performance on different algorithms that you're running on the general purpose CPU. All of this means that what we were doing with microcontrollers previously, where we were trying to do the impossible on them, like get them to do, desktop level algorithms, all of this now is going to be highly accelerated. And so it's actually it's going to be the future with what you can do with these is going to be very exciting, because the level of algorithmic complexity and the amount of things you can do on a processor that big is going to be pretty amazing. The key point with microcontrollers and why microcontrollers versus an application processor, it's just you have a size win, you have a cost win, you have a power consumption win, and you have a heat generation win. Like basically a microcontroller doesn't need to have DDR memory and an eMMC flash drive to hold the operating system, and then memory to hold all of the data the operating system loads. That's like one of the problems, for example, Linux, is that it is a dynamically linked system. You can't just have a giant static application that includes everything you ever wanted in Linux for your system. It's impossible to generate. You're always stuck shipping dynamic libraries. And the reason that is bad, it makes sense for a desktop where you don't really care about how much space you're using, but for an embedded system, it starts to hurt you because you really can't get the envelope of Linux shrunken. I mean, you can if you got crack engineers working all days and hours trying to get that down. But generally, though, most people are stuck in a realm of, it's just going to be gigabytes in size.
But they do use Yocto and stuff like that to slim down the kernel for those.
Yes, you can use those, but there's a limit, though. Like an example, let's say you want to add Wireshark to debug something. Well, you just added a gigabyte to your image. I got to play with Yocto and BitFake, and ran into a lot of fun issues with that. Then also the issue of hey, you're working on a branch of a fork that's way out of date of the Linux kernel. So how do you get like a patch upstream into your particular out of date branch to fix a bug? And those all things were whole nightmares.
So this is bare metal, your libraries, or are they?
Yeah. It's all bare metal.
Yeah.
So you get the kind of the best performance there, but no, the key part is that then we layer something called MicroPython on top of it. So this is the unique. Wow, this thing is really blurry.
I was going to ask you about that. So before we get there, though, let's talk about the core vision. What's the core mission of the company, or OpenMV? OpenMV. What are you trying to do? What is the goal, objective? Is it to
the objective was just really to bring computer vision to microcontrollers. We were just playing around with stuff when we first started, and then it just happened to be that there's an economic viability of making this easier for people. to work with.
10 years ago, that was a long time. So Edge Impulse has not been around that long. They've been around about 6 years, I think. So you're ahead of them, yeah?
Well, I wouldn't say ahead. That's not the word. I mean, they went and got venture funding and have a ton of staff and built up and then got more. I mean, their focus was to do, I mean, so like Edge Impulse wasn't really trying to build an operating system or a community around that. I mean, they built a community around their tool, but not around MicroPython. That's what we kind of worked on. So MicroPython's been a bigger, we're just one branch and flavor of it. It's been a bigger phenomenon. We're putting, Python on a microcontroller. This is valuable in the sense that it abstracts the microcontroller architecture, allows you to move code between different MCU vendors. So you're not locked into one vendor's chipset or another, but then it allows programmers to effectively write code. So an example would be when we're working, and it's particularly powerful with these ML, with these large data sets that you have for machine vision applications, because think about when you're processing a neural network model, the way that works is you have a list of ND arrays, n-dimensional arrays that you feed it, and then it outputs a list of n-dimensional arrays. And so it's these n-dimensional arrays have to be sliced, and you have to go through the values, and some of them can be very large, like up to a megabyte in size of the output heads of some neural networks. And you got to use vectorized, either you write a bunch of loops in code to loop over everything, or you can do something called NumPy, which is a vectorized way of writing code that, let's say you want to sum all of the columns together in an array, a NumPy can do that in one line of code or one call. So they'll have a function for that. And this stuff is all generally helpful because for these large models, that's what they're designed with. They're designed with desktop libraries that programmers do stuff like that on the desktop. They do vectorized function calls. And so MicroPython natively has a way for you to take the same code you write in the desktop and then deploy it on a microcontroller. And as the data sets and things that you're processing get larger, when you go from traditional microcontrollers, you might be processing only a few bytes of data per se is the high level result. Like if you look at IoT systems per se, they might have 1 or 2 sensors that you're looking at, but you're looking at like processing camera data feedback. It's a really rich data source. And so given that, you really want to have a higher level processing so you can provide the mathematics and functions to handle that rich data source, basically.
So what was the seed for you to get into this, the computer vision area, and also this? What was the seed for the idea for OpenMV?
My co-founder. Well, I worked at Carnegie Mellon. That's what I've worked at with the school at Carnegie Mellon, and the lab there. I was at Anthony Rowe's lab and Ilya Norkshvish. I can't pronounce his name right. Lab, and they did something called the CMU Cam back in the day. And so that was the Carnegie Mellon Cam. It was the first microcontroller vision camera. It was a SX48 processor running at like 48 megahertz or so, and it was able to process a single camera image, line scan, and so that could do color tracking of one object. And it was a very interesting system. And it sold pretty well, and I wasn't part of that, but I did the CMU Cam 4, and so the 4th version of it, and that was fun. And then I put it down after I graduated. I didn't do anything with that anymore, and basically I was interested in doing computer vision, I guess, still. And my co-founder Ibrahim was doing this project called OpenMV, and so I joined his OpenMV project was piggybacking off of what I did at CMU Cam, actually. So he was like, oh, this guy did CMU Cam. I can do a better camera than him. And then I found him online and was like, hey, I'd like to help you. Because at that point, I had left Carnegie Mellon and wasn't doing any cameras anymore.
Right. I see.
That's how I got started.
It's like a progression. Because sometimes you come across something and then you kind of build on it later on because it's something you understand and deeply. But was it a passion of yours? I mean, was computer vision, or just microcontrollers or embedded systems, or are you trying to solve a particular problem? Because
I would say embedded systems are a passion. It's fun. It's really frustrating to get anything to work, but once it does, you feel very happy.
Yeah. So you're a true blue engineer then.
Yeah, is that how you felt when you do anything, Lance?
You know, it's interesting because people used to ask me, because I grew up in England and I studied in England. I did my degree there and I got my job there, and a couple of jobs, different types of jobs, doing all sorts of things. I worked for IBM Research Development Center. I was working on the first PostScript printers. So I was doing some very interesting stuff. I worked on transputers. You're too young for that stuff, but that's basically the first multi-core, multi-threaded kind of environment. So I did a lot of different things, and people used to ask me, what do you do? Because you don't get paid very well in engineering, certainly in firmware you don't. In the US, a little bit better, and Germany a little bit better, because I spent time in Germany as well. But I wasn't chasing the buck, where a lot of my fellow students went into the banking area and they were better off financially, but I really enjoyed the problem solving and tweaking. And I used to say to people, I get paid to play.
Mm-hmm.
I loved
Have you
it.
ever seen the investment bankers? Their lives kind of suck. They
100%. But no, they weren't doing investment banking. They were doing sort of like, the banking information systems. They were working on those kind of software. I had the opportunity to join a company to build out a trading system and stuff like that. But I actually introduced 3 of my friends who ended up doing it rather than me, because I didn't want to go down that path. So I wanted to stay hardcore engineering, because I used to take an idea from idea stage all the way through to the final market, the hardware, the industrial design, the electronics, the firmware, everything. So that's what I really enjoyed, was bringing an idea to life. Not just doing bug fixing, because some of the projects and some of the companies I work with, there was an element of that, which is improving the product. I worked in telecoms, frame relay stuff, which is old hat nowadays. But they had a frame relay boxes which will allowed companies to communicate between cities, optimizing the trunk. They were sending the traffic across. So there was, but I enjoyed the problem solving, and that to me was, and I still do that now. I mean, even with my own company, I've built the whole software stack. We built the software in-house. I built the servers that are hosted in the data centers. It's all on Linux. It's all on Proxmark, CUD virtualization. I did all of that, right? So, because even though I didn't learn that at university, I applied those basic fundamental principles of engineering to any problem. And that's kind of how I approach life in general. So I really enjoyed engineering as a discipline. I still do it now in my other areas of work, and even in the way I architect my company. So I don't think it goes away. The only thing I don't enjoy is the people side. I don't enjoy it, because people are very unpredictable, and it's difficult to figure out, because as an engineer, you have parameters that you work with, which are defined most of the time, defined parameters. What you can put together to get stuff done. Whereas with people, one day is totally different from another. So that's the problem I've been working on, as a business owner. But as an engineer, I think right now I'm actually heavily into the LLM area, deploying them locally on my own hardware. We're also leveraging all of the different platforms. We're actually optimizing our own company and reducing headcount around the use of large language models for content, and also for outreach and phone work and all sorts of things. So I'm heavily into the technology as it evolves. So I've kind of kept up with it, rather than just, a lot of people just kind of go by the wayside. They just get stuck in a rut, a lot of times. So I've been lucky enough to be involved in the cutting edge side of the tech space. So I enjoy it, and like you said, it's the satisfaction of arriving at a solution to me. But that's short-lived. You got to keep going, and you got to find another problem to fix then, right? But that's what keeps you going. It's like anything in life, right? You got to keep evolving. So what about talking about large language models? Obviously, you're deploying them in a use case environment for computer vision, but what about, all these co-pilots and stuff like that are emerging now? Are you looking at that, sort of bringing those kinds?
No. I mean, I'll be honest. We're focusing on a subset that's really more like core technology enablement. For the people who are doing the LLM work and such, that's not something you can do yet on microcontrollers. No. And so ours are really focused on CNNs. That's what we're kind of doing right now. And this might sound like, oh yeah, you guys are doing what was done back in 2017 and such, and 2018 and 20, basically we're lagging like 5 years on the tech stack. But that's fine though, because we're basically targeting a niche where no one else is. And I guess it's better to kind of go for a monopolistic kind of thing and something where you can dominate and provide the best software than go into the battle arena and get murdered. And so for us, the microcontrollers are something we kind of know we want to provide value on. And a benefit of them is that there's a huge amount of demand for building out these electronic systems, because as I mentioned, as I showed you here, this is the concept here is you could put this camera in a light switch or anywhere really. It's so tiny, it's so low power. And so that's something that folks haven't really explored. That's very different. But also the next gen version of that chip will be able to run LLMs on board. Not though at the same level that you're thinking. So the concept would be tiny language. So if you could get an LLM down into sub 32 megabytes or so, that's going to be, of course, a very stupid LLM comparatively. But for one particular task, like count the number of people in a room, might be an LLM in the future that people would want to deploy. Because if you look at like object detection models and such, what we're really doing with that is we want to answer a question, which is, what, given some number of objects in the field of view, tell me how many there are, right? And so you could skip the processing the output of the LLM step of the object detector step and just have it provide the actual final result, which is.
Well, I was actually referring more to the toolkit of actually rolling out the software that will run on your microcontrollers. That's what I was referring to when I said LLM,
okay.
not the actual LLMs deployed on microcontrollers. You don't have the capacity, you don't have the horsepower to do that. But I was more talking about the actual toolkit, because a lot of the tools now with these copilots are accelerating the code output and allowing people to build out systems which are going to spit out, let's say in your case, they're going to be optimized machine code which you can put onto a microcontroller. Because that could be something you could tag on maybe to your toolkit for use cases. The other thing I was going to mention too,
it's not necessary, honestly. The way things are right now, it's you just use. So what we've done is we tried to abstract everything to kind of the desktop level for folks. So we have, well, first let me back up. It used to be that you would write custom computer vision algorithms and you would use all these different computer vision operators, right? Here's the sad reality of everything. A neural network beats you in quality, but then also, since there's a neural network accelerator, by definition, it's also 100 times faster than what you could do with a CPU. So not only is the neural network going to do a better job than what your hand-coded thing is going to do, but it's also just going to outperform you from having an accelerator. Given that, where's the value of doing computer vision stuff? Really just basic geometric methods and image manipulation methods for like cropping, scale, rotate, remap the image, basic stuff like that for, simple image handling. And otherwise, it's all into running CNNs. And then for handling the output of that, you use something NumPy to handle the output. So that's the vectorized math library I mentioned. The LLMs write those very well. So like if you ask a ChatGPT to write NumPy code for you, it'll output like perfect NumPy code.
Yeah.
So from a code generation aspect of things, just a simple chat interface is enough to get you through that part of it. For actual firmware work, though, it's totally useless generally because the libraries are brand new. And so no one's seen them before. Helium is brand new, so there's very few programming examples that the LLM has to learn from. It'll typically just give you code that's a total lie if you ask it for something very confidently. So from the development standpoint, you still have to have the skill, but from the user standpoint, we can kind of get everyone to the point where they'll be able to leverage an LLM.
I'm heavily into the home automation space as well. Particularly open source. So I'm a very ardent supporter of open source. I try to deploy open source everywhere I can, including home automation, with Home Assistant. So I can see lots of use cases for, your products in those kind of scenarios, not just for home, I guess, home automation applications, but also in a factory or in an office or something like that. I mean, you also mentioned counting as well, because again, when I was at this trade show, it was all manufacturing, chip manufacturing primarily, digital twins, and also, actual, looking at surfaces and of PCBs and all that sort of stuff. So, and also I've been to a couple of other trade shows in Asia as well, where they've actually used a lot of this computer vision to look for defects on the PCB and layouts and stuff like that. So what sort of funky use cases do you think you could see the deployment of OpenMV in, other than the standard ones?
Well, since this is being recorded, I can't necessarily mention the ones that I know are some funky use cases. So,
okay, all right, okay.
Because I have a few customers who've emailed us and they have some funky use cases.
Okay.
Well, one of them that's straightforward is it's automated reading of events in industrial sites. So an example of this will be, we've got a lot of folks who have random equipment from yesteryear lying around, and they want to be able to read to monitor that equipment. So this is everything from seeing thermal to reading thermal data, like checking what the temperature of something is through thermal imaging. This can also be monitoring gauges and other things like that. It's pretty much process monitoring remotely. It's not sexy at all, but it turns out to be a very, very large market of devices that can just be sold to stare into different system, effects happening everywhere. Why do our devices become useful for that? We can run on batteries. So the ability to run for years on battery power, thanks to it being a microcontroller. The way that works is you power cycle. So you turn on, do something, take a picture, process it, send out metadata, and then go back to sleep. And basically you wake up every 10 minutes or minute or so and do that whole step. And because you're basically off in low power mode for the majority of your lifetime, that means you can last on batteries for a very, very long time.
Yeah.
And this all of a sudden brings smart intelligence to kind of literally everything. Even like for a security camera, like Ring system, for example. Imagine if you wanted, like, here's a interesting idea that I was talking to people at the conference about, the Embedded Vision Alliance.
Yeah, how was that way?
It was good. It was good. A lot of people interested. Took a lot of flyers. Hopefully they'll sign up for the email list. I don't know. We'll see. But what I wanted to mention is, okay, this guy, right? He can run Qualcomm's got a model out that does facial recognition. So you give it a face, and it runs at about 7 frames a second on board that one. And the model's doing like something on the order of a couple hundred, not a couple hundred, but like literally tens of billions of multiplies and accumulates, right, for what it's doing.
Right.
So it would take forever for it to run on any other processor, but it runs in 7 FPS on the AE3, and it outputs a facial embedding score. So given 128 by 128 image, it'll give you a 512 byte score, hash that is basically the person's face ID. And that can then be used to, look up in a database and unlock a door or something like that, register a person in a facial matching. And so you pair that with a face detection algorithm that finds the bounding box of someone's face. Now you have the ability for a camera that's about that big, a quarter by a quarter, to do facial recognition, like actually good quality, not like barely making it, but like, decent smartphone level facial recognition. And we've also got a time of flight sensor on board, so we can kind of see depth in front of it, so we can tell between a piece of paper and not, per se. Anyway, putting that all together, though, now it is possible, for example, to make a door lock. Imagine a smart door lock that runs on 4 AA batteries. And every time you can put the PIR sensor into a motion detection mode, where, not the PIR sensor, you can put the distance sensor. It's the ST flight sense distance sensor. And so you can put that into a beaconing mode where it just like blinks every second to like illuminate, but very low power. It doesn't give distance measurements. It just, no person or no, presence or no object or no object, basically.
Right.
That can do an interrupt on the processor to wake it up from deep sleep. And now when you walk home, your door lock, right, can detect when someone's standing in front of it, wakes up when there's a presence of someone there, runs the face detector, looks for a face and unlocks the door based on it seeing a person, right? And you know, registers to your face, and now you have a door unlock and lets you in. No need for a key anymore, or even typing a number or anything like that. You just walk up to the door, put your hand, or you could have like a touch sensor, you know, that wakes the processor up. Put your hand on the handle. The second you do that, it wakes up, checks your face, and then unlocks, just like your phone, right? Like, why don't we have a face detection unlock door handle? And the answer is simply that battery power wise, it would have been untenable before, because you would have killed your door lock batteries within a day, you know. And so with a system like ours, now you have the ability to actually get a year of battery life, for example.
So you get a year's battery life on something like that, yeah? That's interesting.
Yeah. And it's because, again, the whole thing is that the system is in a low power state. So it's in the microamp current draw. And when it detects motion or activity, then you wake up and do something. And that's really the key point there, is that you have the quick boot up where you can be up and running the application in less than a second, which is required for it to be tolerable. This hasn't been done before. It's not really because of the power consumption per se of the Linux system. When it's running, like, it would be tolerable to accept, you know, like a Raspberry Pi doing this. But the issue is that you have such a long boot up time that you would be aggro on your door if it had 30 seconds or a minute for your door to boot.
So how does it compare to other? Because I actually looked into this as well, computer vision, because I'm actually an investor in another company in Australia, in Perth. We do manufacturing. We manufacture steel reinforced retaining walls. So there's a factory that produces them, and we have installers that install them. So I was looking at using computer vision to track movement of the goods throughout the factory floor, and to measure efficiencies and time motion studies and all that sort of stuff. So there are lots of cameras out there that can do that, you know, that they do also, you know, obviously capture the image, they record the image, but they can do also some computer vision. So what sort of competitors are there that you got out there, or is there a sort of technology that's currently available?
No one's really doing the microcontroller stuff per se right now, so it's pretty new, honestly.
Okay.
It's I mean, I guess there's a certain unappealing factor to it, in that you mentioned recording. Like, one of the things you do to get the power consumption win is you don't record.
Right.
And that's something like everyone wants to do, is, hey, it's a camera, it's got to be recording for some reason, even though a lot of people don't want those recordings per se. Yeah. And you don't even want to know about that. So, I mean, that said, you could take a picture and send that to the cloud, but, you know, again, with some of these things, if you're trying to do a privacy security-wise system, maybe you don't want to actually take a picture of every person who's going in your door at every point in time. So these are the things that you have to trade off between. Not to say it's impossible, but if you want to record that video right now, you're talking about turning on the Wi-Fi system on the chip, and that draws a lot of power to transmit, and then it has to connect to a base station. I guess you could do it via Bluetooth, but Bluetooth doesn't let you do large data packets. So Bluetooth Low Energy doesn't.
Oh, you could buffer it. You could buffer the data into RAM or some sort of system.
Well, that's the thing. The RAM is flushed when you go into deep sleep. So
yeah, right.
And then we have very limited hard drive space, only just like 8 megabytes or so on board. Yeah. We're using tiny chips for this kind of stuff. So it gets into like, where do you want to optimize? Now, for the N6, which is our more powerful system, you could do a SD card of up to 1 terabyte. Yeah. Very easy then to support a lot of data record. But then that kind of, it brings in again, like, what's the goal? Is it to have the maximum battery life and be a door lock, or is it to be a door lock that records everything? Yeah. And then then it becomes a security system, and then, you know, it starts becoming, you got to figure out what exact targets you want to have at that point. Sure.
Now, talk about the language. You selected MicroPython. What was the impetus behind that? I mean, I know MicroPython, or Python in general, is used a lot in machine learning. Was that the main reason for using that?
No. We just picked it back in 2015, actually. Ibrahim started OpenMV with MicroPython support. And honestly, if it didn't have that, I probably wouldn't have joined, because I thought that was a revolutionary idea to have a Python programmable microcontroller. I mean, this is what I knew, which is a C programmable ones Yes, people use them everywhere, but the tool chain that you have to ship with someone with these systems is very large and unwieldy, and that can make people's lives difficult. But more so, it's excuse me. Besides for that, it's more of you'd be surprised, but a lot of programmers are really comfortable in Python and not C anymore.
Really?
And so, yeah,
I'm
they
old,
are.
mate. I'm C, and C++, mate.
Yeah, no, it's really not. It's not the lingua franca anymore. It's Python has become that. I mean, people who I mean, I think programmers learn C, but generally though, you'll find that a lot of folks just never touch it in their day job anymore. Like they just write like Python and JavaScript are the two languages that a lot of programmers deal with nowadays.
Not in my domain, they don't. They're still very hard. C and C++ is the key for sophisticated systems, and because Python is interpreted language,
Yeah.
right? C++ is compiled language, right? So for optimization and efficiencies, it depends on the size of the system, depends on what you're building, I guess. But definitely complex systems are built in C and C++. I mean, Linux is still written in C. So
no, for sure. I mean, I write all our code in C. Like what we develop
Yeah.
OpenMV is in C. We don't write it in Python for sure.
Yeah.
No, but I mean, like that's why we chose it though, because it's if you want to
Yeah.
actually have users for your system, a large base of them, they're typically going to be in Python, and pretty much all the machine learning code is in Python.
Yeah.
Directly, robotics, ROS code, also a lot of it's in Python directly.
So let's
so
talk about Rust. What do you think about Rust? I mean, are you a supporter of Rust, or where do you think?
I've never used it myself directly, and I don't really. I mean, I'm not sure what problem it's solving, to be honest. Like people say that it's yes, you can have like okay, I use Qt to develop desktop code with C++, and Qt has pretty much everything I need as an object structure. Where if you delete an object, the object deletes its kids.
Yeah.
And stuff like that. And so like I don't really have memory leaks thanks to using Qt. And so it's like, yes, I get why Rust would be very interesting if you were using the standard C library all the time, but there's packages such as Qt for desktop programming, which I use, that kind of get around that problem. And so there's never been really a need to use Rust. That's kind of how I look at it.
Yeah, I don't know, to be honest. I mean, I've seen the whole evolution of these languages, and there's nothing really that's come close to C, because C is kind of like, it's kind of assembler and high level together, and it's got all of the power. But obviously, you got to use it with caution. I think that's where the Rust is kind of, because before C was that popular, I used Pascal and Modular 2, and this is kind of, and also Ada. Right, so Ada is still used in military, right? Because for those reasons, mission critical systems.
Yeah.
I think Rust is kind of trying to be an Ada, I think, of modern day. I think they're trying to do that. And I think there's a lot of talk about that with, in the programming space about how Rust is making big inroads. I don't know. I think the jury's still out. I think it's just a matter of adoption. Adoption is very hard in programming, as you know, with languages. To get critical mass, it takes a long time. I think that's why I think C and C++ and C++ has been evolving. And I think it's C++ 21, I think at the moment, or even be 25. I'm not even sure, but they've got multi-threading built into the language and all sorts of things. So I think that these old languages, because there's a lot of legacy code, so you can't just come in and it was like the old COBOL days, right? Where you can't just replace all of that stuff. You got to keep it going. And that's another problem with complex projects, particularly in the military and stuff like that, where there's billions of lines of code or millions, tens of millions of lines of code.
Oh yeah, I mean, for sure. I'm not trying to replace C. Like we write a ton of C code for OpenMV. It's more about like what do you want your users to do. So what I wanted to show you right now is just a concept from our camera, like what our users experience for writing stuff.
Yeah.
First, here's an example script, right? Let me show you one of those. I think that would be helpful. Let me pull up the examples. So, okay. That's not the best one. Okay,
so you wrote this?
Yeah, this is just VS Code, right?
Okay.
No, what we've done is we have this. So this is like this is a script that someone would write on the OpenMVCAM to make it run.
Yeah.
Okay, so kind of way it works, we have something called sensor that is the camera sensor. So you reset it, you set the pix format frame size, and you skip some frames to give the camera time to settle. And then we have this data structure called ROMFS. So this is a very interesting idea that is not really something a lot of programmers for microcontrollers have seen, but it really changes the game. Basically, on the OpenMVCAM, we have a section of memory, let's say 24 megabytes, and that will be allocated to a ROM file system. And so this is not the FAT file system, it's going to be read-only, but it's a data structure where you can embed files and folders, and every file in that is memory aligned to 16 bytes or 32-byte offset. It's very important because the neural network accelerators require memory alignment for data structures they're accessing. The value of this structure, though, is that we can create the ROMFS on the computer. We can do all the compiling to compile network models to an optimized format that runs on the NPU on board, and then we can flash them all as one giant file system to our microcontroller without editing the main firmware.
So let me ask you a question about the training model, right? So training the model itself. Let's say I wanted to use it in my home automation. And I wanted to sense presence, right? So any person, right? So any physical, is it possible? Because I know you got these presence sensors, which use radar, really, I guess. They use radar to sense presence, which is a different method altogether. But could you train your model quickly to sort of just look for human form, I guess, and then trigger some interrupt? Which
well, we already have a model for that. There's tons of YOLO models that just only find people.
Okay.
That's baked in. That's out of the box experience.
Okay.
Protection.
That's cool.
Yeah.
What about a cat? What if I wanted to do it for an animal or something like that? Is it easier to repurpose or reprogram the model, or is there?
Yeah. So there's a model called there's something called the COCO data set, which is about 80 different classes, and cats and dogs are included as one of the classes.
Okay.
So you'll have models called YOLO that are able to you only look once. They're able to do object detection for all like your basic objects.
So once the detection happens, let's say the system wakes up, it sees something, it detects something. Does it trigger an interrupt, or how does the interface work? The electrical interface on your board?
Yeah. You have I/O pins, so you can set an I/O pin to have a rising or lower, falling interrupt, and then you can go to sleep. So you call a function called machine.sleep, and that'll put you into a low power mode. And then that interrupt triggers, you wake up and start executing code again, or you restart the script. If you went into the lowest power mode, you wake up and reset.
Okay, so there's no data. It's mostly triggers. Is there any data exchanged, or I guess, like you said, there's no recording?
No. You can record. It's a full operating system using MicroPython. So you can open files, you can open folders. There's actually battery-backed RAM available, which can keep state between different system runs. The only trick is if you start recording, then you start adding complexity. So the N6, our highest end one, does support SD cards, and you can do up to 2 terabytes with SD cards with that. And so there's no problem if you wanted to record videos or pictures on that. It's just the aspect becomes, if you're going to be doing that, you're going to start to sacrifice the low power nature of your application.
Yeah. So have you done some, has there been any case studies done on power drain or power, in different use cases? Have you guys done?
No, we're too small to have done anything like that, but we have our customers typically use the product in various ways. And so what we see from them is the most robust thing they like to do is just transmit the data immediately and then go back to sleep.
Right.
So they don't really want to keep data on board the device generally. They prefer to connect to the internet and push it to the cloud as fast as possible. So this can be either pictures or just metadata, but generally the idea is to get it off device. That's what they like to do.
So let's talk about the Kickstarter program that you got, or the Kickstarter project.
Oh, wait. I wanted to go into this technical detail before we move off languages.
Okay, yeah, sorry, go for it.
Okay. Anyway, this is a very short script, but this example will run a person detection model on board and kind of find people.
So this is Python, yeah?
Yeah, it's Python. Now what I want to
do, going into that while loop, right, at the bottom, so you've done some visualization, you've gone into a while loop, and you're
take a snapshot.
Okay, taking a snapshot, right? Okay.
Then it's going to call this function called model.predict on the image.
Yeah.
And but basically, predict returns a list of n-dimensional arrays, which are
you're passing the image into that call.
Yeah, passing it in, and then the output of that is a list of ND arrays. So this model only has one output, so we grab the 0th output, and we convert that to a list of numbers, and then we combine that. The zip function in Python basically so labels is a list of labels from the disk.
Mm-hmm.
Like we can, you basically, when we open this file, the person detection, it'll have a list of labels in there, and we're able to get that access to that list of labels, and we combine it with the outputs of that person detection. That's what zip does. It like imagine zipping two things together, like one side and another side being combined. And then we use a lambda function in Python, which allows us to define a key to sort the values by. Mm-hmm. In this case, x1 is the scored when you zip them together, and then we reverse it. And so that'll give us a nice sorted list of labels for person or no person, with scores. And this example though works for literally any object classification. So like if you had like 80 plus classes or such, it would handle that with the same exact code. But the thing to mention there, the reason why Python starts to get powerful though, is what did I just do here in this one call? I grabbed I ran a model, neural network model. It output a list of numbers. I combined two lists of numbers together. Each, the first two elements are combined. The second two elements are combined. The third two elements are combined. I then sorted them by scores. All these things are C functions. You could definitely write this all in C, but it's easier to express in Python once you learn Python. And then it starts to get more powerful when you learn something called NumPy. So for actually processing the output of those models, okay, the best way to define it would be, so YOLO v8, which is one of the modern versions of the object detection algorithm called YOLO that people are using to draw bounding boxes around stuff. It's going to output a 2D array, so two-dimensional array. Every column in the array is a detection, and then you might have 5,000 possible bounding boxes that it could generate, for example. And then in the rows, the first row is the x coordinates of a bounding box. The second row is the y. Third row is the width, height, and then the remaining rows after that are class scores. So if the model has 80 classes, then you would have 84 rows. So you'd have 80 rows followed by, and the first four would be, you'd have 80 rows, but the 84 rows, and the first four would be these values followed by 80 rows of classes. So just imagine an array of 5,000 times 80 elements. Mm-hmm. It's a very large array. And so NumPy can do stuff like, this is a very complex call, but once you learn NumPy, and again, ChatGPT helps write this stuff. What this line of code here says is, get me the output tensor 0, then for every column, I transposed this, so it's a little bit different. I'm too into it now. Okay, so if it wasn't a transposed way of operating, it would be like this. We would transpose the array to fix a performance issue, so I was explaining it poorly. But what this would say then is starting at, let's say, row 4 and down until the end of the array, and then for every column, find me the max across all, columns, for example, and then return an array of that. And so that one line of code might compress, this call, for example, if you were to write it in C, would probably be about 3 loops,
Right.
or so, nested inside of each other with a lot of indexing.
Mhm.
And then with NumPy, it becomes very, very trivial, very, very simple. And so, yeah, it's totally esoteric to get into when you first start seeing it. It took me a long time. And to be honest, I was totally against it. But the key unlock is as you start dealing with a ton of data and you're processing lots and lots of data, again, like, in this example, a 5,000 column matrix by 84 rows, it starts to become very, very obvious that having the power of being able to call these vectorized instructions that basically work on an n-dimensional array becomes very, very powerful. Anyway, so total geekery. I mean,
No, that's
totally,
fine. No, it's good. I mean, my audience will appreciate it.
but it's all about the concept that this is how you level up as a programmer.
Yeah. I see what you're saying. Yeah. Look, it's. I understand it. I mean, it's it's chunking, right? I mean, you don't if you don't have to be in the weeds. I mean, that's why we have libraries. That's why we have reusable code, right? We don't want to write everything from scratch. You certainly don't want to go down to assembler, right? It just depends on the use case and also how much optimization you want from a particular system of programming. Let's say if you have Python and you can get away with it spitting out binary code that you can deploy on a microcontroller and you're happy with the efficiency versus C, then it's fine, right? Depends on your use case. Like that's why people use Linux a lot, because they've got powerful machines out there, powerful hardware that can run that, even embedded Linux. I mean, they don't have to worry about, the size of the code or the RAM or the CPU. But with your situation, I remember the birth of MicroPython. I remember it was a big thing, right? Because I remember the project. It actually was a Kickstarter project, I think, way back when the guy actually built it, right? He built the hardware. He built the hardware and the language which went with it. So I think it's definitely a very good way to go forward. And it really, particularly your particular situation, which is computer vision, it hooks very well into what other work's being done in computer vision space, because there's a lot of Python use there as well. So talking about
that's why it's it actually makes I mean, it was kind of an antithesis to embedded engineers. They don't ever want to agree that this is a good way to go. I get it, but at the same time, what you just said, though, just think about the number of developers creating LLMs and writing desktop code and web code, and how excited they'll be that they can now work on a system like this and build some kind of cool project. They're going to be very happy that all of a sudden there's a way that they can get on board.
100%. I think what's happened is there's this kind of, do you remember the old days when it was like very disparated? You have the application developer, system developers out here, we're using Python, PHP, web development, all that sort of stuff. And then you got the hardcore embedded people, assembler in C mostly, then it was C++. So there was complete separate schools, right? But now they've all coming together with the birth of the internet and connectivity, IoT and web apps. And then now you got things like MicroPython. You got all the optimization. They're almost like this blurring effect going on, which is great for general programming, because then you can migrate down the stack from computer science people that did computer science and electrical engineers that did electrical engineering, and they mostly use C and C++. Because I used to say, well, people used to tell me, can I go and do embedded systems development? I said, not really, if you've done a computer science degree, because you don't understand the underlying hardware, right? And you're never going to have an appreciation of how to debug hardware if you've done computer science, because you haven't studied it. Whereas I think there's more opportunity now with what you've just said, with these kind of toolkits, that people can actually get a bit further down, and they can actually build their own systems, even if they haven't got that underlying university training. So I think it's definitely a great time to be alive when it comes to availability, what's out there. I mean, even in single board computers, I mean, there's so much out there, and it's pretty much dirt cheap. You can buy it for nothing now. You can buy tools, open source, and otherwise, if you want to deploy something, do something. Actually, I think we have an overwhelmed situation right now. I don't know if you agree with me, but I think there's so much coming at you. I mean, in the way of what's available for developers, that it's difficult. There's a problem with choice now. It's like, where do I go? Because then there's another shiny toy just up, come up. So what are your thoughts on overwhelm?
Yeah, no, I mean, you asked about this and then our Kickstarter. For sure. There's a lot of stuff going on out there. I think what matters is what's supported, right? So definitely a lot of companies release the next dev board with high intent specs. And then, I think one of the things is like specs doesn't actually mean it's going to run that fast. Like you can have all the amazing specs if you want, like if you don't, an example, the reason I mentioned something about transposing the array of that YOLO V8 model, right? All right, so we have a customer who's early to our system, and they're using the OpenMVCAM to run YOLO V8. And so they actually got a 80-person Coco class YOLO V8 running on board. And they were like, hey, it's getting 3 frames a second, but we think it should be running at 10 frames a second. And I'm like, oh, yeah, it definitely should. What's going on here? And I went into the code and realized that we were working on the way the YOLO V8 output works. It's transposed, so you have to access the class scores. They're stored in a column versus a row. Normally, you want to have all the records in a row. Why do you want to have all the records in a row? Because that is what the cache is designed to suck in. And so, if you're accessing memory, if again huge array, if you're accessing one column each time, you're getting a cache miss per access, basically. So the algorithm it took about 181 seconds to perform that single max function I showed you. That took 181 milliseconds to run on this array. And I was like, good Lord, why is it so bad? And I realized, oh yeah, this is totally bad on the memory because the way this is designed. I went and transposed the array. I cut it down to 8 milliseconds from 181.
Wow.
And the reason I mention that to say that you've got a lot of new systems coming out. If no one has done these optimizations for them, where are you going to be on things? You still need to have a community and resources put behind a system to really push it to the max. I remember a lot of the Rock Pies, for example.
Yeah.
They had released them and they had MIPI-CSI2 interfaces. And then I saw plenty of people just connecting webcams via USB. And I was like, but you have like a MIPI-CSI2 interface for a camera. It's way better. Why don't you use that? And they were like, oh, we don't know how to get the drivers working. So we're just going to be connecting USB webcams to these dev boards, which is the inferior way of putting video into a Linux, single board computer. And fundamentally, those problems came from just there wasn't the community or development effort, needed to support all the features because a new system was going to come out next year that replaced it, and it was, it wasn't worth it to develop and work on these things. And so it does help to have like what Raspberry Pi does, which is a standard development system that is well supported, where everything works and people can get behind, for example. And so we're trying to bring something similar to the microcontroller world.
But you have quite a good community yourself, right? The OpenMV community is. How is that? And do you get feedback from people that you kind of take on?
Yeah, we do.
Yeah.
Mm-hmm. Yeah, yes, that's the case, and that's how we got a lot of Kickstarter backers who helped us out and such, and got us to help get the Kickstarter off the ground. Kickstarter isn't as valuable as it used to be anymore, I guess, because of all the scams that have happened on it. So
yeah.
It used to be a lot bigger, but it's definitely toned down from what it used to be. But it's still a thing, though. It's still helpful.
What about Indiegogo? Have you tried to put it out there as well?
No, I haven't. We're only doing one campaign. I don't want to run another one. I think this will be our last Kickstarter ever. It's so much work and pain to do.
Yeah, that's what I was going to ask you. So what's that experience been like, when it comes, because I've actually bought quite a number of things from Kickstarter, and some of them have been delayed and so on. So what's the general experience and demand and, dealing with customers, and what's that whole experience been for you?
So far the customers haven't been too unpleasant. The first Kickstarter, there were more unpleasant that we did. but we messed up on that one. There was a bunch of production issues, and that was back in 2016, so a long time ago. But I would say it's more just like the way the margins, everything. It's all hard to run a business on it. Like you can easily end up losing money on a Kickstarter.
Yeah,
that's why a lot of people who do it go out of business after they produce a Kickstarter, because it's very easy to not understand the cost of everything. And I think a lot of folks want to give really low prices to everybody to entice them to buy. But then if you do that, you got to worry about, Kickstarter takes a fee. Then any advertising services that you use take a fee. Advertisement is required almost because there's so much going on, as you said. You have to advertise for these things to even help your Kickstarter. So then that's a percentage of the revenues that you were going to have. And then, I don't know, it's shipping also is a thing now, and then tariffs also coming into play.
Yeah.
So all of these things kind of make it really, really hard to be successful doing these kind of, actions, basically.
So let me talk about the future. Where do you see, I mean, obviously things are moving very fast in the general AI space with so much money pouring into that space, but how is that trickling down? And do you think, where do you see embedded AI?
Well, that's what we're hoping with the OpenMVCAM AE3 and N6, is that it's really going to explode the market for what people can do. And there's going to be so much stuff coming out. I mean, with the AE3, for example, we're expecting just everything and anything being able to have AI in it. We're going to be selling the system about $80. And so, I mean, at that price, sub $100. I don't know if we can keep that forever. The tariffs made everything more expensive, so it might end up being $100. But still, we're going to have a low price for that system. And yeah, it really enabled like 200 billion operations per second. As I told you, facial identification. All of these things are coming to you soon. And then next gen will have support for LLMs. So it's going to be a crazy future. Like your toaster will have, your toaster could have a camera in it and identify who you are so that your toast setting is correct for whatever you want.
Well,
the toaster about to put in.
It's only like, I guess it was about 10 years ago that I was actually at a meeting with some students out of a university. I was invited to talk, and we were talking about Wi-Fi connected appliances, like your toaster and your kettle and stuff like that, And I was just, at that time, I was like, why would you do it? It's like, why would you just go, that the kettle's boiled, right? Why would you do it, right? So, and I was just saying to people, look, it's not about, the fact that, why do you want to do it? It's just that it's convenient. People like that sort of stuff. And then, of course, now that's all being done now, right? I mean, everything's got Bluetooth and Wi-Fi, and you're on an app, and all the appliances are talking to one another, and all of that sort of stuff. And I guess the next iteration is, having machine learning in these devices.
Yeah.
And when I was at this trade show, they were showing that, a little bit of that. They had this induction heating pad for cooking food and stuff like that, and it was all there was machine learning running on it and figuring out optimizations of temperature for the different types of foods and things like that. So yeah, it's obviously going to come into a lot of different things, not just for computer vision, but general sensor node stuff as well for processing any kind of sensory information from our environment. Will probably go through a small machine learning model and then kind of go out perhaps for greater processing. Like IoT is a big thing for that sort of stuff.
I think that the challenge with a lot of what previously had of IoT is just that the applications are boring, fundamentally. Like I got a Wi-Fi connected stove in my last place. I was in a condo and they had a Wi-Fi connected stove, and I was like, I had an app for it too. And I went and looked at the features, like, oh, I can set the temperature of my oven remotely.
Yeah.
Which is something I don't care about ever doing.
No, exactly.
I'm there to cook, so
that's right.
Why do I need to do that? So that was like one of the things, like Wi-Fi connected fridge, which I was like, but there's no camera inside. So I was looking for the camera and I couldn't find it. I'm like, why does it need Wi-Fi then if there's no identification? So this is the thing. I think people said IoT 1.0, didn't go anywhere, and I think the fundamental reason for that was just that it was all focused on boring, like mostly boring applications with very, very little amounts of data actually being transmitted comparatively. And I think the addition to machine learning and ML has the ability to transform that so you actually can do interesting things where, you know, the IoT part actually provides some value then. And so I think it's going to be very different what we have with these new IoT embedded systems that have ML capabilities, strong ML on board. The stuff you can do is now much, much greater, basically.
So let me ask you this then, right? This is to do with security, you know, privacy, right? So, you know, I'm a very ardent supporter of technology. I embrace it, I use it, and so on. But there is this question about too much surveillance, too many cameras, right? Too much data gathering. What are your thoughts on that?
People are going to do it if it provides convenience. This is also where I said, though, like, you know, the power consumption thing versus security, you actually have a real trade-off to make, because the person who says, I got to record everything all the time, their power consumption is going to be bad, right? Versus the one that says, oh, I'm not going to record everything all the time, and you're going to have great power consumption. And that then means battery life, which is something consumers can directly appreciably feel. Again, that smart door lock situation I mentioned, that will, you know, could be a product based on could be easily built into a product based on the OpenMVCAM, right? The person who's recording everything and anything there will appreciably have a lower battery life, or than the same than a system that doesn't do that. Just because initiating the recording and, you know, booting an SD card, these things all add little draws to the power consumption that you have to deal with, and that'll add up over time. And so I think you'll actually run into a challenge where you'll have someone adopt actually the concept that we're just not going to keep data on things no one cares about, and you'll actually have the market will actually reward that behavior from the convenience being better than the person who is adopting approach of I need to log everything and anything, and then they have a worse performing system. This idea of being able to do battery powered devices, I mean, for something that's plugged in, for sure, I can totally see then that you don't have to make that trade anymore. You can just record everything. But when you talk about more of these battery powered devices that have an easy install and don't have power that they're going to be working on, it does make a lot of sense on how folks are going to think about these applications. I guess an example would be, imagine a Ring doorbell, a Ring camera that you buy from, you know, Costco or Home Depot or whatever. Helped my dad put some of those up on a house we remodeled, right? Okay, we could only put 2 up because we had to replace the Stones lights in the house. But we wanted 2 on the left and right, but there was no solution. Like, what do? You can get a solar panel based one with a battery, but if it turns on too much, it's dead. So these are the kind of things where the concept of not having to run conduit and power and electrical for certain devices really explodes the number of things that you can have. Like let's say you want to put a camera in the middle of your field, right? Let's say you have some land. You just want to stick a camera down that, you know, watch for coyotes or bears walking through or something like that, right? You know, yeah. My dad, we have some land in the country, and that's actually a challenge, right? And so these kind of things, the power consumption matters, but, you know, more so when a more industrial use case would be, I don't know, let's say you want to do parking lot and you want to like find all the license plates of cars in the parking lot. You put a camera per parking space that was able to track that. But if you had to run conduit to each parking space, it'd be millions of dollars of install cost. If you can run that on batteries, things change. So I don't know. I would just say I'm predicting that there's going to be some market forces for security versus reliability will actually start to be something that we'll find a nice equilibrium there.
Sure. Let's do some quick fire, rapid fire, just to finish up. Right?
Okay. Yeah. I'm almost out of time. So yeah.
Yeah. What's your favorite AI application outside of work?
Favorite AI application outside of work? I don't know. I got no life, so.
Welcome to the club.
Netflix, maybe. It thinks it's not an AI application. This is TV.
Yeah. Okay. What about most used tool or app where you're prototyping new hardware? Is there a particular tool that you use more often than not?
Tool or app? I don't know. I would say a nice plug is I've really been happy with Altium. I know a lot of people hate Altium for the massive cost it charges you, but once you get over having to pay money for something, surprise, then it actually really helps the design process, having 3D CAD integration and the ability to have a vault online with all your files. Makes it super easy to show people stuff. And then we have all the Altium files on our website, so folks can zoom around and look at the 3D, look at our designs very, very easily and understand how anything is done, which I really like.
Coffee or tea to power those late night coding sessions?
Do coffee, and I'm finally at a point where I just take my coffee black now, no cream anymore.
Okay, so that's your typical brewed American coffee, which is
just Dunkin' Donuts, Dunkin' Donuts coffee. No, but I started out, I needed to put cream and sugar and everything in it to make it palatable, and now it's like, wow, I'm just drinking straight black coffee. This used to be unpalatable.
Yeah. Okay, great. Okay, one book or podcast that influenced your thinking lately?
One book or podcast? Let's see. There's a book by there's a book called Jump by the chairman of the Larry Miller. He was the chairman of the Jordan brand. And he writes a book about his life story. It's very eye-opening. Let me just say that.
Wasn't that made into a movie?
Not yet. Not yet.
Oh,
It just came out.
Yeah.
Larry Miller, though, he's the chairman of the Jordan brand, but he has a secret that he lived for his entire life, which is he was actually a convicted murderer when he was a teenager. And he went through an entire re-education program, served many years in jail, but managed to come out and provide value to society, and helped launch Michael Jordan's sneakers and get that to be a very successful brand and such. But he had a heart for he hid that secret for 40 plus years of his life, basically, and it crushed him inside, and he was like, I finally have to write a book about it and come clean with something I've never told anybody, basically. And so a huge amount of bravery, I can imagine, doing that, because from him, he always imagined, he writes in the book multiple times that his biggest nightmare reoccurring was he would wake up and the police would be there to haul him off to jail.
I used to have a reoccurring nightmare, but it wasn't about murder. It was about not completing my degree.
I took 6 classes at once in school, and I had something similar to that.
Yeah.
Where I wake up and I'm remembering there's an assignment due for a class that I was taking that I forgot and didn't show up to class for the entire year.
Yeah, those kind of nightmares. Okay, last question. If you had to build a new OpenMV demo in 24 hours, what would it be?
OpenMV demo in 24 hours. Yeah, actually, I want to build that face detection example. We just got the parts of it together, but I haven't yet built the demo script. So that's the hope, is I'll have that done soon and people can use it, actually. The face recognition, sorry, not detection example.
There you go. There you go. All right, my man. Well, it's been a pleasure to meet with you. I've really enjoyed the call. I don't keep you too long because I know you're busy. And so, look, it's great work that you're doing with you and your partner there, your co-founder. I want to support you with your work. So, I'll put this video out on my channel as well. And I'm also going to go on Kickstarter. I'm going to go and buy one of your boards anyway, just for my own interest and play around with it. And I'll also promote that to my community if people want to play around with it, because I think it's a great, the work that you're doing, and the use cases, there's just so many use cases, particularly if it's battery powered. I think even I can think of so many use cases in the home or in the factory or an office where you could use this tech, or you can even build your own product if you wanted to nowadays, right? So I think that this work is fantastic. You guys are awesome. So thanks so much for all your contribution to the community. And I think, and you're obviously getting a lot of love from your own community there through this. And of course, code sharing as well. I guess you guys are code sharing, which is awesome as well. So yeah, thanks very much again for your time, and let's stay in touch for sure. And where are you based, by the way? Because I'm going to be.
I'm in San Francisco. San Francisco, Lance.
Oh, you're in San Fran. Well, I'm gonna have to pop down there and have a coffee with you. A real coffee, that is. Not the
Yeah.
homebrew
Where
stuff,
are you
right?
located? Oh, you're in Texas, Austin.
Well, I'm actually not in Texas at the moment. I'm actually in Kuala Lumpur right now because I was in Singapore, for the trade show. So I'm in KL at the moment. So I kind of move around a lot. So I'm actually going to be in San Fran as well, but not probably not this year because I got a lot of other trips to make. But definitely, I think you went to this. You said you went to this. Was it a trade show that you went to recently?
I was at the Embedded Vision Alliance conference in May. That one
Yeah.
happens, and the next one I'll be at is I'm planning to go to Austin for the Embedded World US. I think that's the one of the conference.
When's that on?
There'll be Embedded World US in Austin sometime this year. I think November-ish timeframe.
Well, I tell you what, if you're going to be there, let's hook up there and have a yarn and have coffee, get to meet each other there in the flesh. Yeah, I'll check it out myself because I think I want to make a few trips to conferences because when you go to these trade shows, you get to see a lot of people, and because I went to one in Nuremberg in Germany. That's the biggest one, right? And that's huge. I mean, that is just, you can't get around it. It's just so much going on. So, and walking around, I don't know about you, I'm getting a bit old now, right? 5 hours of walking around a trade show all day, it takes it out of you.
Well, I did that at CES. I did the CES conference, and it was 10 miles of walking a day. That was some challenges. So looking forward to that. Embedded World North America is, I think, what we're going to give it a shot, and we'll see what's going on there, which should be pretty interesting. So I am definitely interested in going to that one. That said, it looks like it's not too ridiculous. It's pretty small comparatively, but trying to find where do you book for it. Oh, here we go. Embedded World North America. It's October 8th to 10th. Oh, right.
So what about, let me ask you this then. Let me ask you this. With some of the, because there's a lot of trade shows at the beginning of the year in America, right? I mean, in San Fran as well, sort of January, February is when it all kicks off. And of course, CES, when is that's kind of on that sort of time as well.
Beginning of the year.
Yeah. I think there's a lot there at the beginning of the year. So I got to visit quite a few cities. I got to go to New York. I've got some customers there, and down to Texas as well, and across to North Carolina. And then of course there's San Fran, of course, the Silicon Valley. There's heaps of companies there. But I think, hitting trade shows, I enjoy it because it kind of brings everyone together and you can kind of interact. It just saves a lot of time visiting people in different parts of the country. So yeah, definitely I'll look into that for October, but have a great, it's an evening time there for you now, right?
Yeah, pretty much 6 p.m. or so. 6
p.m. So you're just you're not knocking off because you're a 24/7 kind of guy like me, right?
No, I'm 35, so I'm not as young as I used to be. No, I'm actually writing. I'm writing Helium code right now, so I'm going to get back to it. Got to get this performance optimized for a customer. It actually speeds up all of our networks. So once we get this in, it should provide a 4x speed up for pre and post processing of all neural networks that we run on our cameras. So always trying to get the best speed and performance for things. That's what I'm up to now.
Fantastic.
All right. Appreciate it.
All the best. Take care.
All right. Bye-bye.